In this video, we're going to discuss circles. And by definition, a circle is any set of points that are equal distance from a center point. And in a circle, we call this the center of the circle. And the center point is referred to as the point HK. And HK itself is equal distance, which means that every point on the circle is the same distance from the center. And generally speaking, we say that in a circle, this right here is what we call our radius. So we're going to be able to find the radius in the center of a circle and then write it in two different forms. The two forms we're going to write is what we call our standard form, which helps us easily identify the center of the circle. Standard form looks like this. It's x minus h squared plus y minus k squared equals r squared. And notice from this form we can identify the center at h and at hk and the radius at r squared. The other form that we can write it in is what we call our general form. And the general form is found by rearranging the standard form. So the general form of a circle is going to be x squared plus y squared plus some constant, which we'll call cx, plus another linear term, which we'll call dy, plus a constant e is equal to 0. And in this form right here, we're going to learn how to rearrange this form using the completing the square method to actually go back to the standard form. So let's go ahead and try some of these problems now. So let's look at example A. In example A, the goal in any circle that you graph, if I want to write the equation, all I have to do is identify two things. I need to identify the center at HK. So remember, we have to find that center at HK. And I also have to find the radius R. So for this circle, all I have to do, identify the center first. Here's your center. And the center is at the value of 0 on the X and 4 on the Y. So the H is 0 and the K is 4. That's the first part. The second part is identify the radius. Well, because every point is equal distance from the center, by definition, that's the radius. Notice that we can put these 4 points here and get radius to be equal to 2. Now we can plug into our general form, our standard form, which is what we're going to write all of our circle equations in. So we're going to write these in the standard form. And recall that the standard form says this: x minus h squared plus y minus k squared is equal to r squared. So we write it like this: x, this minus means change the sign whenever you get here. Well, our first term is just a 0. So we'll just write it like this: x squared plus, the next one we have a positive 4. So we'll do y and change the sign of positive 4 becomes minus 4 squared is equal to our r squared here. Our r was 2, so 2 squared is just 4. And that is the equation of this circle. So again, in this process, all we're doing is identifying a center. Once we identify the center, we go ahead and find the radius. So let's try another example. In this problem, notice this. The center here is at the value 2, 3. So the center is at the value 2, 3 here. And our R for this particular graph, put points out here. And when I look at this, I see that my R is equal to 1, 2, 3. So my R for this graph is 3. So writing it in standard form, again, we're writing in x minus h squared plus y minus k squared is equal to r squared. So x, change the sign on the first h on h, so that positive 2 becomes a negative 2. squared plus y, change the sign on the next one, so positive 3 becomes a negative 3 squared is equal to, well, our r is 3, so it'll be 3 squared, which is just 9. And also notice from this circle, we can also pick up other key features that we know about graphs. For instance, its x-intercept is at this value right here, which is 2, 0. It has a y-intercept occurring here. And to find that y-intercept, we know that the x value is 0. So to find the y-intercept, we set x equal to 0, and we solve the equation for x. There's also a second x-intercept here a second y-intercept here that we could find if we needed to. But just notice that these are just key features that we could find if we needed to find them. But in general, to find the equation of a circle in standard form, all you have to know are going to be the center value of the circle and the radius of the circle. If we can graph the circle, then we should also be able to find the center and the radius from an equation. And remember that the equation, and this is written in standard form, is going to be written as x minus h squared plus y minus k squared is equal to r squared. So all we have to do is identify h and k and r from this equation. So here's h, here's k, and here's r. And because this is a negative, that means you need to change your signs here. These negatives mean change your signs. So I know my center has to sit at the opposite of those values inside of there. So my center is at the values 3, negative 2. And then this is the square. This is the square of r right here. So I need to take the square root to get there. So my radius is equal to the square root of 36, which is just 6. And we tried this problem over here. Same concept. Again, we're looking at the formula x minus h squared plus y minus k squared is equal to r squared. So I'm going to change signs on that value. And notice for y, there is no number back there. So it's understood to be a 0. So our center is, change that negative 4 to a positive 4. And the y value is 0. So you have a center at 4, 0. And we have an r. You have to take the square root of whatever your number in the back is. So it's square root of 49. That's equal to 7. So we can also go the opposite way where instead of decomposing the equation, we can actually write the equation in standard form. And it's just like we did with the graph earlier. All you do is you change the center value, change the sign on the center values, and you square the radius. So for this first one, we're going to write it as x, this minus 2 becomes a positive 2. X plus 2 squared plus y, this positive 4 changes sign, becomes a negative 4 squared. And it's equal to whatever your radius is squared. So we're going to write this as 1 squared, which is just 1. Over here, 0 means that you don't have anything to go with the x. You don't have an h, so that will just be x squared plus, change the sign on the negative 3. We need to change the sign to a positive 3. So write it as y minus 3 squared is equal to, and now we have to go and square the radius. So we're going to square 4, and we get 16. So this is writing it all in standard form. And when you write a circle in standard form, it's easy to see the actual center, and it's easy to interpret the radius. The next set of problems that we're going to do is going to focus on what we call general form. And in order to actually graph, because that's what we do with general form, when we get it to the graphing of standard form, we have to use completing the square. So we're going to complete the square on these equations to get them to standard form. And so when we complete the square here, this is called general form. It's general form because you see the x and the y here. We want to get it to standard form. So to get it to standard form, the first thing we do is we're going to line up the variables together. And what I mean by that is we're going to put the x's together and the y's together. So we'll write this as x squared minus 4x plus y squared plus 2y. And we're going to move this constant we're always going to move whatever the constant value is over. In order to move it, that means it's going to change its sign. So this will equal, changing the sign of negative 20, it'll be at positive 20 now when it moves over. And what you want to do is you want to line up the x's together like this and the y's together like this. And what we can do now is we can complete the square. And when we complete the square, here's what we're going to do. Whatever this term is by the single variable x or by the single variable y, you're going to cut it in half. So for instance, I'm going to take 4, I'm going to divide it by 2. And whatever I get for that, I'm going to square it. So 4 divided by 2 is 2. And then 2 squared is equal to 4. So I'm going to rewrite what's in my parentheses as this. X squared minus 4x plus 4. So I'm going to add 4 to this equation now. Because what I've done is I made it into a perfect square. And I'm going to do the exact same thing with this 2y part. I'm going to take 2 divided by 2 and square it. So just like I did over here, I did 4, because I had a 4 right here. Took 4 divided by 2 and squared it and got 4. Here I have a 2, so I'm going to take 2 divided by 2 and square it. 2 divided by 2 is 1, and 1 squared is 1. So I'm going to write this as plus y squared plus 2y plus 1. So I'm adding plus 1 to it now. And that's equal to, here's the next part. That's 20 plus whatever you added, plus the constant that you added. So I added a 4 and a 1. So I'm going to add plus 4 plus 1. And the nice thing about this is what you've done is you've just completed the square. And what completing the square means, now inside of here, this is all factorable. And it factors into a perfect square. And it's a very simple square to factor. And here's how you factor it. Whatever you got when you cut this number in half. So when I take 4 cut in half, I get 2. I'm going to rewrite it like this. X minus 2 squared. X minus 2 squared. Take whatever you got to keep the sign. So the negative 4, so I have a negative. I'll put the negative here. Then I'm going to take 4 and divide it by 2. When I take 4 divided by 2, I get a 2. That goes here. Plus. Same thing here. When I took 2 and divided it by 2, I got 1. So I'm going to go y, keep the sign, plus 1 squared. All of that equals 20 plus 4 plus 1, which is just 25. And now that I've done this, I can see that my center, the center of the circle, is going to be at positive 2. Remember, we changed the sign, positive 2. And the radius will be at, then the center, the h will be at 2. The k will be at negative 1. Changing sign. So negative 2 becomes a positive 2 when you take it out. Positive 1 becomes a negative 1 when you take it out. And then our radius is equal to the square root of 25, which is just 5. And then I can graph this function. In order to graph this function, here's what I do. I'm going to plot the center at 2, negative 1. And then I use the radius to go up, down, and right and left. So I'll go up by 5. I'll go down by 5. I'll go right by 5. And I'll go left by 5. And when I do that, I can close these dots off to the basic shape of a circle. And here's your circle. So again, in order to do this, though, you have to complete the square. And completing the square works because when you go through this process, you're always going to get a squared term here, a perfect square here, and a perfect square here.